Chapter 5, Lesson 1 of Advanced Algebra, we're going to begin looking at a new function, and this is the quadratic function. We've dealt with linear functions and absolute value functions mostly this year, so a new function, but again, we're going to kind of follow the same process. We're going to look at the standard form of the equation, we'll look at some of the key points of the graph, and then we'll look at how that applies to real-world situations, making scatter plots, doing regressions, and then we'll take a look at some different things that we can do with the graph as far as solving for the x-intercepts and the zeros and those types of things. So this we'll take a look at the graphs to begin with, so let's go ahead and do that. First of all, let's look at the equation. It says that a quadratic function is a function that can be written in the standard form, ax squared plus bx plus c, where the a value cannot be a zero. The domain of the quadratic function is all real numbers, so there's no x value that's excluded from being used in this function. Now this is a very important part of the where we're going here is these standard form and what these terms are, especially with the quadratic. This first term, which has the squared with it, is called the quadratic term. That's what makes the equation quadratic, is the fact that it has one of these. And you'll notice that it says a cannot be 0. Well, why can't a be 0? Well, if you think about that for a moment, if we substituted in 0 for a, we would have 0 times this x squared term, which would be 0. There would be no quadratic term, therefore it wouldn't be a quadratic. So that's why we have to state this restriction as far as the a term goes. That cannot be a 0. The term here is called a linear term, and that's because the exponent is a 1 here, x to the first. That's a linear term. We'll talk more about that as we go through the years when we look at polynomials and degrees. And then the last value here is called the constant term. This will be a number, okay, no variable with it, so that number will never change. Both of these can change if you change the a and the b, or if you change the x. But the c can never change because there's no variable attached to it. So this is the standard form of quadratic. So we broke that down into some of the key points here. This is the standard form. The a cannot be 0 because if it were, it wouldn't be a quadratic. It must have a quadratic term in order to be a quadratic. So we want to do a few examples. What we'll ask you to do is determine if the example is a quadratic or not. So if we had this right here. Now the tricky thing, if there is such a thing in these, is the fact that if there's some multiplying that has to be done, you'll want to multiply that first to determine if it's a quadratic or not. So if we distribute the 7, we're still going to have a 7x to the first power. That's the highest exponent, so because 1 is the highest exponent, that would be a linear function. So this would be a linear expression. Alright, let's take another look. Now this is what I'm talking about. Now you might have to remember FOIL, and actually in a subsequent video I want to show you how to multiply these out. So we'll use the distributive property and I'll show you that. So when I multiply the x times the 3x, that's going to give me 3x squared. Well, there's that quadratic term, so I don't need to go any further. I know there's a quadratic term, so it's going to be a quadratic. Next one here, if I multiply 3x times 2x, that's going to be 6x squared. Again, I have the quadratic term, so this will be a quadratic as well. Alright, I'll pull a few more through. You can stop the video if you want to guess, but I'll move kind of quickly here. This one's pretty easy. The x squared is right there, so that's obviously a quadratic. This one here, if you distribute the x times x would be x squared, so this would be a quadratic. Now this is weird, and this is one of those where you want to, oops, I just showed you the answer, almost. You'll want to remove the parentheses, so you'd have x squared plus 5x minus x squared. The x squared minus x squared would make the quadratic term go away, so leaving you just this term, so this one would in fact be a linear. Okay. Actually, that's the next one. Oh, I got a whole bunch of them all grouped together there. So let's do this one here if we can. That x squared should be over here. That one's kind of weird, but that's linear. Distribute the x, you're going to have a quadratic term there. Okay, so that's how you determine if it's a quadratic or not. So in the next video, we'll take a look at some more characteristics of the quadratic. We'll look at the graph and some of the key parts of the graph.